Hi, welcome to our first level 3 probability concepts video. We're just going to introduce some basic probability ideas again. In mathematics, probability is used to investigate chance. It's measured on a scale from 0 to 1, and we write them either as fractions, decimals, or percentages. Theoretical probability is probability calculated based on the theory of what should happen if an experiment was to be conducted. We often use the following formula to help us calculate what the theoretical probability is. The probability of an event is equal to the number of favourable outcomes divided by the number of total outcomes. For example, in a class of 24 students where 15 are male, 8 are female, and 1 student is non-binary, what is the theoretical probability of selecting a student at random and that student is a male? Well, here's our formula. The event is selecting a student that's a male. We have 15 favourable outcomes and 24 total outcomes. So the probability of selecting a male is 15 chances out of 24, which we could simplify or convert into a decimal or a percentage. If all the outcomes all have the same chance of occurring, then we say they are equally likely. For example, selecting a card from a standard pack, which is 52 cards, if the pack is shuffled well, all cards are equally likely to be selected. So the probability of getting each card is the same. When we conduct a mathematical experiment, we can use the results of the experiment to estimate the probability of an event occurring. We often use the following formula to help us calculate what the experimental probability is. The probability of the event is equal to the number of times an event occurs divided by the total number of trials. For example, flipping a coin 20 times, what's the probability of getting a head? Well, here's our formula. The event is getting a head. The number of times it occurs, we can read that off the graph and we get 6 heads, and the total number of trials is 20. So the probability of getting a head from this experiment is 6 chances out of 20. And again, we can simplify or convert to a decimal or a percentage. Now, the theoretical probability says each side has an equally likely chance of coming up. So we should get 10 out of 20 heads, or 0.5 is our probability. And quite often we find that the experimental probability takes a wee while to actually show what the theoretical probability is as well. Now, theoretical probability is probability calculated based on the theory of what should happen. And experimental probability, which is often called long-run relative frequency or relative frequency, is probability calculated based on what actually happens. Okay, let's talk some probability notation now. When we see the P, it means probability, and whatever's inside the brackets, we have the event that occurs. But let's talk about our inequalities, where some students find it a bit tricky. And let's put up here a reminder what our inequalities are. So this is the probability that x is greater than 4. Well, we've got 2 types of data. Continuous data is data that is measured and can be any number, including decimals. But discrete data must only be whole numbers because it's data that's counted. So when we say probability of x greater than 4, for continuous we have an open circle on 4 because we're not allowed to include 4 and any number bigger. But for discrete data, it must be whole numbers bigger than 4, so we must start at 5 and 6 and so on. But if we say greater than or equal to 4, for continuous we close up the circle and any number bigger, but for discrete we can now include 4 and any number bigger. When we say probability of x is less than 4, for continuous we have an open circle and any number less than 4, and for discrete we have whole numbers less than 4, so that's 3, 2, 1, 0 and so on. But when we say less than or equal to 4, we close up the circle for continuous data and any number less, and we have any whole number that is 4 and less for discrete. Now this is the notation to indicate a number between 1 and 4, but I don't have my equal to, so for continuous I have open circle and any number in between. For discrete data, the only 2 numbers I can have are 2 and 3, whole numbers. But when I include the equal sign as well, for continuous I close up my circle and therefore any number in between, and for discrete I have whole numbers from 1, 2, 3 and 4. Right, that's our first video. Thanks so much for watching.